Okay, this is lesson 6.2. Going to graph absolute value. So far we've graphed linear equations, we've graphed quadratics. Last lesson we graphed exponential equations and exponential functions. And then this lesson we're going to graph absolute value functions. So if you remember, I told you very specifically that when we were graphing parabolas, so this is a parabola right here. So this is quadratic. That we wanted to make sure that it curved because absolute value also has a vertex. It also opens up and down, but it doesn't curve. It's in a V shape. So we have to make sure that we're very distinct about how we graph these so we can tell the difference between absolute value and quadratic. But let's start by looking at the equation. Now we've already solved some absolute value problems. This time we just set it equal to y. So you know that the absolute value has the two lines around it. Things can happen inside the absolute value, outside the absolute value. You can have negatives in front of it, numbers added or subtracted outside. We know that these aren't because they don't have the bars around it. This has an x squared, so this would be quadratic. This would be linear because it just has an x. Whoops, that didn't write very well. There we go. So looking at the examples down here, let's go back to the beginning. It's V-shaped. It can open up or down. We know that this one's quadratic and we know this one's linear, so these are not absolute values. The tricky part comes again when you're looking at the tables. So they have a similar vertex to the parabola, but a parabola doesn't increase at a steady rate. A parabola increased like maybe the first time by 2, the next time by 8. This time it has a vertex, but it increases by 1 or it increases by a constant amount, just like a line does. So it's really difficult sometimes to tell the difference. Is it absolute value or quadratic because there's a vertex? So right here's the vertex. But also, is it linear because it's increasing by a constant rate every time? Whoops, I guess those were technically decreasing by a constant rate every time. So -1, +1. So you really have to look for both the vertex and the constant increase. So on this one, we can't really see the vertex because this one is going to increase by 2. This one doesn't increase. That's because that's where the vertex is at. The vertex is in between them. And then this one then is decreasing by 2. But still constant, what's happening. Okay, so looking at tables that we've seen before, this one adds 2 every time. So it's a constant, but there's no vertex. This one, there's a vertex right here, but this decreases by 2. This increases by 2. Oh, but this increases by 6. So it does not increase at a constant rate. It's a little bit more tricky to tell in a table based on that. Okay, so how do we graph these? Well, we're going to start by graphing this in a table. So take -2, and I know this is kind of tiny for you guys to write. If you need to write it over here in certain parts of this, you can. So take the absolute value of -2 plus 3. So the absolute value of -2 is 2. 2 plus 3 is 5. Same thing here, absolute value of 0 plus 3. So that's 3. Absolute value of 2 plus 3, well, that's back to 5, so I bet we're looking at a vertex right there. Absolute value of 4 plus 3 is 7, and the absolute value of 6 plus 3 is 9. So we have -2, 5, 0, 3, 2, 5, 4, Whoops, that wasn't 2. Let's go back and fix that. 2, 5, there we go. 4, 7, and 1, 2, 3, 4, 5, 6, 9. Okay, so even though this doesn't have the exact same ones on the other side, since it has a vertex, it also has an axis of symmetry right here, which means we can reflect this over to the other side. And then we can draw our line. So this is V-shaped. Remember, it doesn't have a curve in it like a parabola does. Okay, let's look at another one here. So this one's got a little more stuff going on. That's okay. We're going to work this out to the side here. And you could put this in your calculator. We'll actually work one in our calculator in class together. So this is 2 minus 4 inside the absolute value. So that's going to be negative on the outside with a negative 2 on the inside. Well, the absolute value of this part right here is 2, but then you have to bring the negative sign down. Okay, so let's do the same thing with 3. So that's going to be negative on the outside of negative 1. Well, this part becomes a positive 1, but you bring the negative down. And like I said, we'll learn how to do these in our calculator too. So 4 minus 4, well, that's the absolute value of, or the negative absolute value of 0, and 0 can't be negative. Then negative 5 minus 4, so that's negative absolute value of 1, so that's negative 1. And negative absolute value 6 minus 4, so that's negative absolute value of 2, which is negative 2. Okay, I see a vertex in there, so that's good. So we have positive 2, negative 2. We have 3, negative 1, 4, 0, 5, negative 1, 6, negative 2. So we don't even have to utilize our axis of symmetry on this one. It's kind of an ugly line. Let's see if we can make it better. There we go. Okay, so I'm not going to do this part for you, but I want you to go ahead and go to Desmos.com. This is on your Chromebook. And try each of these and then describe what you see when you put these into Desmos.com. So you can sketch a quick graph of what's going on down here. So here's where you sketch. And then just describe in words what happens when you put each of these in there. And then we will do some examples of this in class tomorrow.